Okay, now it is getting recorded. Thank you for reminding. Thanks, Chris. Yeah, so what I was saying, I was saying about discrete number. So it is very, very clear that what is discrete number. Similarly, in this chapter, we have to do discrete probability distribution related questions. Therefore, we need to understand only certain events are possible. And I'm going to use slide. So first of all, before going into this, I'm just going to show you my Excel sheets. Can you see the Excel sheet?
Yep.
Okay, so what I'm trying to explain from this Excel sheet, two concepts. Number one is PDF, number two is CDF, and how it works, and how they can be useful. So I'm just going to first, so let's say, this is the salary of someone. January, he received $10,000. February, he received again 10,200, and so on and so forth. All 12 months salary is this. Okay, this salary, if we can plot this, so I have insert, and you can say this is salary distribution over 12 months. So this is a salary distribution, and this PDF probability distribution, or monthly distribution, if I want to know particular month salary, this is very good visualization. What is the salary of May? I can clearly go on May bar. I can clearly understand 11,000. If I need to know June, 8,800. So this is a probability distribution, and this helps to understand the event of individual month. So individual month salary, we can clearly. Now I have a question. What is the salary of more than, after May? If I ask the question, what is the salary after May? Then I have to add June, July, August, September, October. Means I have to add seven steps in order to get the salary after May. How much so instead of that, I can do the cumulative one. So cumulative one month, that we all get the, salary, and we all get the salary check, and you can see the cumulative money, whatever salary check you get, at that statement uses, so far you received this. So basically cumulative is same. So January by February, you receive 20,200, 30,600, and so on. Total in a year, someone received 121,000. Let me draw this distribution. Okay, now I go with. So this is just for concept. What?
And there.
So this is cumulative one. Now it solves our problem, big problem. Let's analyze this. This is always increasing, and it reaches the last month is the total of entire, the last month of salary is of entire, this cumulative is entire year. Now question is very simple. What is the salary after May? How we can know? Very simple. After May, I can have 121,700, and up to May is 51,100. So 121,700 minus 51,100, and I can get the salary after May. What is the salary what is the salary till June? So instead of adding, one by one, I can simply get the June salary up to June, 59,900. What is the salary after August? So, after August, basically I have the 121,700 and up to August is 79,000. So we subtract. So, multiple steps are reduced in only one or two steps in order to calculate the event probability if the event is asking more than, less than, or something. So this is a very simple example in order to understand. So therefore, this is the role of, so basically you understand in a probability, in probability distribution, the individual monthly salary, you can understand, individual monthly salary, you can understand this is a PDF, and this cumulative, you can understand this is CDF. If this is clear, I'm going over the slides part now. Can you see my slides? No? No? Okay. Just a minute. Okay.
Can people mute, please?
Can you see my slides now? Okay. Thank you. I think I need, I request, let me see if I can mute from my side. Okay, so, okay. Okay, I think I muted. Yeah, now it's muted. So, now before going into that, I would like to go into the how we can distinguish which distribution are we going to apply. So first situation, I'm going over whiteboard. So we are going to use few. Number one is uniform. Uniform distribution, let's say your salary is consistent, similar from month January to, let's say 10,000 each month, from January to December. So this is uniform distribution. Or you can say, or you can take another example. So uniform distribution means each event has equal probability. Now, let me go to binomial. What is binomial? You have only two binary option, yes or no, success or fail, and positive, negative. So this is a binomial distribution. Number three is Poisson distribution. Hopefully you can see my screen. Here, average is useful, average or mean arrival rate or average. So basically, whenever you see anything related to that, that is Poisson distribution. Number four is hypergeometric. Hypergeometric distribution. So what is here, in this most important thing, it is, similar like binomial distribution. However, it has finite population. That means N is there. So finite population is given in a situation is called, related to hypergeometric. However, there are different rules are also applicable that we have to see. And number fifth is geometric. And this is related to so just a minute. Sorry. So yeah, hypergeometric Poisson and geometric distribution, which is I have, I think, only one. So this is similar to binomial. However, yeah, it is similar to binomial until first success is not achieved. So basically, if you remember these things, I mean, we have 5 distribution in this chapter. We can easily understand the problem. However, binomial, you can convert binomial to Poisson, you can convert hypergeometric to binomial. There are some conditions that we are going to look into that. So this is the situation. Uniform distribution is very common, therefore but I'm starting from binomial distribution. Let's say I'm just taking one simple question. 3 things are very important in this: pi, or you can say proportion. The second thing, sample, which is n. And third thing, you are going to take x value, x. If you are able to figure out these 3 numbers in any question, you are able to run. And you are able to understand the probability of that event. So yeah, male, female, I'm going to trace, whenever you have 2 options, certainly they are going to be considered binomial. So sample pi, let's say if, okay, let's say your example trace. As of now, how many students are 28? 28 students are there. Let's say, the proportion of female is, I'm just going to write here. Can I write? So let's say, in this, can I write white road? Okay. Okay, let me figure this problem here. So problem is that out of 28 students, there are 10 female students in 28 class. What is the probability that in a sample of 8 students from class, exactly 2 will be female? Chris, is it making sense? So, if you have this, so let me get the proportion of this. So pi equal to 10 divided by 28. We got the proportion. N equal to 8 and x equal to 2. Now let me go over my Minitab. So let me share this. So what is the value of this? If I calculate this in decimal point, so let me go on my calculator. And this 10 divided by 28 becomes almost 0.357, 0.357. Or let's take a round figure of 0.35. So pi is 0.35.
Could you show how you do that process in Minitab?
Yeah, I'm going. So first I'm figuring out the problem, and then I'm going to show you Minitab. Okay. Now I'm going to share my Minitab. Now, can you see my Minitab?
Yes.
Okay. I'm going under graph, under probability distribution. Okay. So basically, it doesn't have a PDF option, but it can give.
Is there any way for you to make it a tiny bit bigger? It's really hard to see.
Yeah, this is full screen. Can't you see my Minitab?
Yes.
So this is full screen. Is it smaller at your end? I don't know, to be honest.
It's fine on my end.
Okay, thank you for confirming. This is recorded, so even if you can come across, some problem, please let me know. So this is a binomial. So number of tries, let's say, this is 10 divided. Oh, number of tries, we took 8 samples. Sample is 8. This is full screen. Is it
if you guys click on view in the top right corner and you select full screen, then you should be able to see it better.
Okay, thank you. So I'm going, so I think this is not from my end. So here we have the option, which is binomial. Number of tries, we are selecting 8 randomly. Probability is 0.35, 0.35. Now I have to see the, area. So area, I'm just, I need how many? 2. Okay, so because it will not give the 2, it gives less than, more than. So basically, I'm just going to use just so that you can understand something. Now here you can understand the event probability. So if you can see my cursor, if I select 2, if I select 8 students, what is the probability that, no one will be female is 0.3%. It's a 0.03. So my question was, what is the probability if I select out of, my class 8? What is the probability that exactly 2 will be the female? So this is coming 25%. And this is the, probability distribution of entire thing. So this is coming, if you can see, 0.25. I am going to explain on different way. So here we have calculator. Under calculator, you have a probability distribution. Under probability distribution, you have binomial. Now, situation is here, probability, cumulative, and inverse. So if I explained the salary. So if you are going to exactly see on particular event, use the probability. If you are going to say more than, less than, and all, cumulative one. If you are going to check inverse, then this is. So I'm just going to see probability because our case is exactly 2. So number of tries, I took 8. Number of event probability, I took 35.35. And now I have to do input constant. Input constant is 2. Now you can see the answer right here, if you can see my screen. So you can visualize this probability under graph, and you can get the numbers using this under calculator. But the graph is giving more clear picture, visualization, what is the meaning. Now I'm going to explain one more option here to see. This is event, and this is corresponding probability I'm going to see. So let's say event 0, 1, 2, 3, 4, 5, 6, 7, 8. Why I'm using 8? Because I selected 8 sample. What is the probability that all 8 will be female? This could be also possible. Therefore, I can't have more than 8 event. Now I'm going to see the probability of each of them. So I go under calculator, I go under probability distribution binomial. I use exactly the same numbers because 8 and 35.35 is not going to change. I'm going to use here the input column, which is event. And I'm going to use storage into probability. Now look into that. I hope I can make it bigger. Can you see? So this is event and this is corresponding probability. What we have done, you can see 0.031, 0.13, 0.25, 0.27, and so on and so forth. If you look into this probability distribution that we draw, exactly same values we can see here, on individual number. If I put the cursor on this and 27, 18, another important way to check this, I'm just going to do, I'm going to share tables, how you can use the tables also. Wait a minute. So I need to share my screen. Screen 2. Okay, I hope I'm going to flip this. Can you see this?
Yes.
Yes.
Can you see the distribution table?
Yep.
Yes.
Okay, look into this, check this. N equal to what we have for N? N 8. We took, sample size 8. What was our probability? We don't have, this, they have 0.3, 0.4, 0.5, and we took 0.35. So let me make this change to, instead of this, I'm going to check, I'm going to, for making, comparing, I'm going to make it simple. Calculate and probability distribution, binomial, and instead of, I'm going to just use 3 so that, I can compare. And okay, now I have the probability of 0.3, which is, this. Now look into this. So 0.3 and this is 8. So I'm going to see, this is my, look into this, 0.5, 0.05, 0.19, 0.29, 0.25, this is our distribution for N equal to 8 and pi equal to 0.3. Look into this, exactly same, 0.57, 0.19. So basically, this makes our life easy, instead of going through and this table and all, you can visualize what is happening. Otherwise, this tables doesn't make, very much sense. But when I studied, I studied using these tables because I did not have computer and only books. So look into this. Another important thing, what is the sample here? So this is binomial distribution. Up to what sample it is going? Pi N equal to 16. Why? If you have more than 16 or, sample size is bigger, then all distribution follow normal distribution. Therefore, it has limitation up to this. So if you have a small sample like 10, 12, 8, this is good way. So I'm not, this is pi. Now our question was, what is the probability of having exactly 2 females? So I'm just going to look into, so this is 8. This is started. This is for 0. This is 1. For exactly, this is 29.62. What is 29.62? Now I'm going to give the answer here. So I go under probability distribution and binomial, and I'm going to give here, instead of this, I'm going to choose exactly 2. And now, so exactly 2 here, you can see 29.6. See here, 29 point. You can see the same result here. So this is the 29, this is the, so this is binomial distribution. So for example, I take one more example to make it easy. So I'm going on the whiteboard again, and then I will come here. So this is, now I'm going to frame one more question so that you can understand. Okay, this is, I hope you can see my inner community. In a community event, 20% attendant, or 20% people, those who attended, got COVID positive or found COVID positive. But identity is not revealed. Government revealed that this event happened, and 20% are positive. Out of that, community event, if I take a sample, of 12 people, what is the probability that more than five will be positive? Do you understand the question? So how we can apply this binomial distribution? So my question has been clear that government revealed that event happened, or any soccer match or anything, that 20% people found positive. And if you take a sample of 12 people, what is the probability more than 5 will be? So I'm going again on my mini tab, or I'm just going to share the screen. So here is the situation. Now I go under graph so that you can probability distribution. This is I took the sample of 12. Probability is 20%, which is 0.2. Now my question is that how many, more than 5. So I would like to see. Now here, this visualization works very clear. I would like to see this side, this side numbers. So I would like to use, and let's see. So look into this. So I would like to make it smaller so that it is.
Why
So
did you pick the number 6 instead of 5?
yeah, this is very good question. More than 5, it is not asking, if you know the discrete probability distribution, and I will show you the compound event probability, more than 5. So this is 5 up to 5. More than, what is more than 5? In discrete, 6, 7, 8, 9, 10, 11, 12. Isn't it? Therefore, in this mini tab, you have to put 6, that includes 6, 7. So therefore I put 6. If it says 5 or more than 5, then I would like to put 5. So this is a very technical point, that you have to figure correct X value when you are doing this probability. So the total the probability is about 2% or 0.019%. Oh, sorry, 1.94%, or you can say about 2% probability that more than 5 people will be positive. Now, based on the same situation, I'm going to frame one more question. So if I say less than 5, if I'm asking, the question is, if more than 5, would you? Yes. If I use 5 and more than 5, then I would use 5. Then I would use 5 because that includes 5 in it. But I'm saying all, more than 5, which does not include 5. Correct, Dini? So let's say what I said, less than 5. I'm asking less than 5. So look into this graph, probability distribution, and now it is asking less than 5. So you see, I need, less than situation. So this is less than. Now I will use 4. It is asking less than 5. That means what is the discrete before that? It is 4. So you can see this is the probability distribution. What is the probability of less than 5 people will be positive? 92.74% or 0.9274. Is it making sense?
Yeah, I think it's helping a lot. I know that if you could slow down a little bit when you configure the problems in Minitab, I think that'd be helpful because there's just a lot of things to click on there. And I spent a lot of time trying to figure out what to click.
To be honest, I mean, I did not hear you properly because I think your voice is not very clear to me. If you can please type instead of that, I would, anyone else? Okay, on Minitab. Okay. So yeah, what I'm asking, this is so you can do the same thing. Okay, I mean, whoever asked, this is recorded, so you can watch again and again. Now I'm going to do the same thing using the traditional way and using other way. So this is probability distribution, and I'm going to use what is the binomial here. Now the question less than 5. So here we have cumulative because now I'm going to add cumulative because it is going to add previous. So input constant, what input constant I have to do? Up to 4. And input constant up to 4 because I'm asking less than 5. So here you can see it's a 94. So this is up to 94. Oh, this is 92. Here is different number. Why? Or did we use? So I think the p value was 20%. We are using different numbers. So sorry. Binomial, our 20% people were COVID positive. So 20, we took 12 people sample, and we are just going to see this. So you can see exactly the same number. Now I have to check the same problem if I don't have Minitab. Instead of, I got stuck. So I'm just going to share so this is the our binomial. Now I'm going to make it bigger. So first thing, you are going to check the n. N is 10, n is 12. So this is the 12. What is the 20%? So this is column is 20%. So I'm going right here, 12, 15. So I think this is is it the 12? Okay, this is 15, this is 20%. So this is 20% column. Now look into that, up to 4 or what I did. So this is 20. I'm just getting screwed here. Yeah, here it is changing the column. So this is the column that we are going to use. Now this plus this plus this plus this plus this plus this plus this. I think this is, no, we are going to do up to 4. So this plus this plus this. So up to 4, whatever is up to 4, you just add. So adding up to 4. So this is very useful distribution to make many decisions related to management. I gave the example of COVID. Suppose you are, into project management, different project. The project success rate is, 10, and you have 12, 12 projects in basket. Or which one to choose, what is the probability of second project? What is the probability? You can, make your decision, and based on highest probability or different aspect, you can make decision. So this is binomial. There are 2 types of questions in this. One is exact probability, that you use, exact number, like, what is the probability of event 2? You can get 28 points. What is the more than, less than? So you are going to add, these numbers, you are going to subtract number. Another thing, here, let's say I solved the question using this. So I'm going to use same situation. Let's say binomial. I said, what is the probability of more than 5 people will be positive? Now here the situation, you can see I have to put 6, because more than 5, 6 and onwards. I'm using cumulative. Now I can see this is what happened. This is okay. No. Okay, I made a mistake, so I'm going to rectify that, and binomial here. So cumulative more than 5. So what I'm going to do, I'm going to do up to 5, and then I'm going to subtract from 1, because total probability is 1. It doesn't give, outside. So more than 5. So I'm going to use up to 5, and then I'm going to subtract from 1 to get the answer. So up to 5 is 98%. And so now I have to subtract. So it is asking more than 5. So total probability is 1. Up to 5 is 98. So more than 5 is 2%, that we have already seen.
Cumulative distribution function.
Please mute your microphone, I request you. So this is like the salary. What is, up to May, you calculate. What is more than May? So you calculate the probability, or you accumulate up to May, and then subtract from like total. So here we are 1, 1 is total probability minus 9.98, and we get 0.2. Is it making sense? If it is clear, can I move ahead? What is your opinion? Everyone?
Yeah, we're good.
Oh, yeah, sorry. Yeah, you correct, 0.02. Sorry. Yeah. Thanks, Ted. Thanks. So yeah, thank you so much for, in 0.2, or it is, 2%. Now so if it is clear, now we go to the next distribution. Another important thing, let me go on slide part now. So because that is also important. Every uniform distribution has this slide. So you can understand using this slide, what is the mean, what is the standard deviation formula, though Minitab doesn't, so this is uniform distribution mean and standard deviation formula. Now we go to binomial, you can understand this clearly. Now here you can go, this is mean is n pi. In binomial distribution, mean is n. So like 0.2 is probability, 0.2 is proportion, and 12 is sample size. So mean is 12 point multiplied by 0.2. Standard deviation square root of n pi 1 minus pi. Just I am giving you so that n equal to number of tries, pi is probability of success. And rest, I'm just, I would like to make it simple. So these are other things. Skewed right if pi is less than 50%, pi is more than 50%, is skewed left, and symmetric pi is 0.5 or half, 50-50. So you can see, I don't want you to go into this calculation mode. If you understand, rest is given by Minitab very easily. You just need to understand the problem, just need to plug the numbers, and rest you can get directly the answer. So for example, if somebody is doing this problem, here pi is 10, so exactly 2, and n is 12. So how we can do? I'm going to, so 0.23, I'm just going to show you. Calculate probability distribution binomial. Number of tries, this is 10. And I think we need exactly 2, and this is asking probability distribution. So you can see the answer 23% directly right here, instead of doing all the calculation. Now after binomial, this compound event I was talking, please make sure that this slide is most important in order to figure out the problem. What is the correct x value? Here, like you asked me why I put 6 instead of, I am asking 5, why I put 4 instead of 5, and so on and so forth. This slide gives you all the answer. It gives you clear answer about x value, which x value needs to be used. So if you visualize, or if you keep these things in your mind, I think no problem will be difficult. So only we, this is my experience, only students get confused with x value, which is the, if I ask more than 5, then more than 5 means you are going to include 6. X value is 6 and more. If I ask 5 and more, so basically it is asking 5 and more, so it is asking 5. Less than 5 means x value is 4. So think in different direction, and this is most important again. Now go into the Poisson distribution. Only one number is very important in this. So basically this you can understand, this is usually so the average, let's say on Seattle airports, during 10 to 11 a.m. or during particular time, or during particular time period, these many flights arrive. Average arrival of the flight on Seattle airport is 24 per 10 minutes. Or you can say in any bank, in banking branch, 20 customer arrive in an hour average. So this is basically based on an average, particularly on time interval, but different other average can be possible. So when you see this kind of situation, you can understand Poisson distribution. And so where lambda is average, represented here, average or mean number of events per unit of time or space. So this is very important. So you can identify The mean is lambda standard deviation is the square root of lambda. This is the property. So whenever you are going to transform from one distribution to another distribution, you need to understand mean and standard deviation of all. So here, I'm just taking this example. On Thursday morning between 9 a.m. 10 a.m., customer arrive and enter, this credit union at rate 1.7 customer per minute. Using Poisson formula, PDF and CDF. So basically mean is 1.7, standard deviation is square root 1.7. Again, compound event. So what is the PDF and what is the CDF? So I'm just going to give you what is the PDF and CDF. So graph probability distribution here. So you can visualize what is the probability distribution of Poisson. So I need to look into this. And only one number is requested here, which is 1.7, I believe, if I'm not. Okay, 1.7. You can see more than, less than, all such things. I'm just going to keep it simple. So, but it will not give. So I have to give, some value, which is, then it will give you all the things. So this is the probability distribution of yeah. Okay, now you can see. So mean is 1.7. Look into the what is the probability of 0, 18%. What is the probability of 1? What is the probability of 2? What is the probability of 3, 4, 5, and 6? Now if I draw the PDF or CDF here, I can say, now I'm going to use the exactly same thing, stat, calculate probability distribution, and I'm going to use Poisson right here. Lambda is 1.5, 1.7, and probability. And I'm going to take input constant as, this event. Oh, sorry, input column, I have to do it here, event. And I have to look into this. This is the value of, now I do the CDF of Poisson. So exactly I do, calculate probability distribution, Poisson, and I use only, I change this only, and instead of this, I just do this. Okay, now you can see this is a CDF, and this is, adding up to 100. So if I put one more, this is CDF. Now look into the, I'm going to share with you, this is the situation. Can you see my distribution table?
Yes.
Yes.
So look into this, what is the important parameter here that we need to understand? Only X, a lambda, sorry, average. And then these are the event. So what is our lambda? Lambda, if average, see the table, why table is limited, so you can figure it out. Many problems. What is the lambda value? Maximum is 20. That means average arrival, if up to 20, you can use the, this, therefore the tables are made up to this. But out of that, if you have higher, average, then every distribution follow to normal distribution. So look, our lambda is 1.7 this. Now look into 0.18, 0.31, 0.26. You can see, this is, I did up to 8, you can go up to, 9 or following. So here you can see exactly here that I did here. This you can see Poisson for lambda equal to 1.7. Now the same principle applies that we did in binomial, more than, less than, equal to, what is expected. It is PDF or CDF, you can. So I'm going to make a problem based on this graph, probability distribution. Now I go in this. So this is, average arrival per minute is 1.7 customer in that bank, a credit union. Now I want to know what is the probability that more than 3 customer will arrive in given minute of time. More than 3. So again, more than 3, I'm going to put X value 4 because this is discrete. I'm going to see, because I need this right side. So average in this bank is, 1.7 customer per minute. More than 4, more than what I asked, more than 3. More than 3 arrival is about 9%, 9 or 10%. What is the probability that, exactly 2 customer will arrive in given minute of time? So now exactly 2, I can answer right here because this is my 26%. What is the probability that less than 2 customer will arrive? Less than 2 customer. So I'm going to do another graph and I go this less than 2. Remember, I am asking less than 2, that means 1. So 1 is 14, less than 2 customer will arrive is 49% or 0.49. Is it making sense to everyone?
Yes, thank you.
Yep.
Yeah.
Yes, it does.
Okay, thank you.
Yeah, it's making sense.
Okay, that's great. So this is, once you understand the basic principle, it doesn't have problem. Now, same situation. So this is, like Poisson distribution. Remember, if you Poisson, somebody is saying lambda is 40, or more, or like, more than 20, then, you just convert that distribution into normal distribution. So basically, these two probability distribution are very good when you have a small, a small lambda or a small sample size when you are doing binomial. Now we are going to the, so Poisson, if you can you see my slide part?
Yes.
Now situation is here. How we can use Poisson distribution to binomial distribution? This slide makes, the Poisson distribution may be used to approximate a binomial by setting lambda equal to n pi. So what is the mean? Mean in binomial distribution, mean is, is defined by n and pi. And here mean is lambda in Poisson. Therefore, they can be, so if you know binomial distribution n and pi, you can multiply and you can get lambda value. So when the binomial, in which condition we can use this? So common rule of thumb is this, good is n should be large. Like I said, should be, n should be large, n should be small. A common rule of thumb says that approximation is the n should be large and pi should be small. If pi is less than or equal to 5%, or pi proportion is less than equal to 5, and n is more than 20, then you calculate the lambda and use the Poisson instead of binomial distribution. So this is, rule of thumb. So basically you don't need to do anything, but just, you need to do the multiplication and rest will be done by Minitab. So basically before using Minitab, we need to have multiple, points to consider and think, to craft the problem. Answer is very easy. I don't want you to do handwritten calculation or all, very small, but rest big calculations are done, using Minitab. Now hypergeometric distribution. So this is the third. This distribution uses finite population. It is similar to binomial, however, without replacement. So this is finite population. That means here, if let's say any situation has finite number, let's say in our online MBA program, 890 students or 1010 students are there. So that is the population of our Eastern Washington University online MBA program. So that is a population out of which I'm taking a sample and doing many such things. So basically, if you have situation of having finite number, then you just go for hypergeometric. Maybe skewed right or left or symmetric, a proportion of success in the population is 50%. So, follow the principle. This is the summary slide of N is number of items in the population, N is sample size, S is number of success in population. Now here you go. Similar to binomial, but sampling without replacement from finite population. It can be approximated by binomial with pi is S upon N. So means this can be, if you see N upon N is less than 5%, less than 5.05. Let's say 50 or 40 items out of 1000. What would be the case? 40 divided by 1000 means 4.04. So N the pi equal to, so in that case, you can use binomial distribution. Now go further. So this is, the classic example. Number of iPods in the shipment, 10. So out of which they take a sample is 3. S is equal to number divided iPod in the population is 2. So this is the, problem here, clearly there is a 10 iPods in the shipment, which is you are taking a sample of this. Success, is 2, and then you are using the X thing. So look into the damaged iPod. So here you can first see what is the N pi. So here, you can see, and you can clearly figure it out using graph probability distribution right here. And I go under this, I go under hypergeometric right here. What is the population size? I think 10. Event count in the population. So 2 iPods are damaged in entire 10. You took the sample of 3, I believe. And now I'm not going to change the shaded area, just, so that you can see the entire distribution. So this is 1, 2, N equal to 10, 2, and N equal to 3. So, oh, I think I made some. Just a minute. Sample is 3, N equal S equal to 2. 10, 3, 2. This is correct. So zero, 1, 2 here. So I'm not getting a 0 here. Why this? Oh, here I have a 0, which is red, since I picked, 1. So here you can see 46% of 0 I put damage in this. The second is also 46. I mean, probability of 1 and probability of 2 is this 6%. So 46, 46 and 6. So here you can see 46, 46 and 6. So this is when do we use? However, you can use this distribution if n upon n is less than 5%. You can directly convert this into the binomial distribution. So this is hypergeometric. Again, yeah, I mean, this is, it will take another 1 hour or so because it is all, or you want, I can take chapter 7 lecture tomorrow so that, too much knowledge will not be, I don't want to throw all of together so that, you get confused. If you wish, I can come again at 6 o'clock and I can explain chapter number 7 in very simple and, one by one. Otherwise, yeah, I'm just, giving you. Okay. Okay. Okay, thank you. So this is, I mean, everything is recorded. So those who are missing or something. Okay. So let me finish today this. No, this is my duty, Alinson, and everyone. Actually, if if I can be helpful in your learning, I am always available, because this is not, I mean, I understand myself. I did all these calculations in my life using paper, pencil, and using tables. But now we have all sophisticated tools as in front of us, and then we must use them. So now, again, you can see when we can use the binomial. No, Ted, just use this. So binomial to hypergeometric, because it is highly applicable in nowadays real decision making, because you have all the data of your business process, business decisions, how you can come up with the real probability of real event. Both the binomial involves sample size and treat x as a number. So basically look into this condition, and I think one or two questions in the fill in the blank or multiple choice questions are based on this. Means this situation is okay. I'm going to explain, just let me finish this, Margarita, and I'm going to explain. Wait a minute. And now next distribution is geometric distribution. That is, describe the number of binomial trials until the first success. So let's say, somebody is holding event. Let's say alumni, somebody, what is the probability of first donation come when 7th student will arrive? Let's say, at Eastern Washington University, they are holding an event of fundraising event from alumni, and they invited alumni to have a get together. What is the probability that seventh alumni will donate in the event? So basically this is related to such a situation. So I had favor university 15%. So here again based on binomial thing, 15% of alumni make donation, 85% alumni don't make the donation. What is the probability that first donation will come on 7th call or 7th alumni? It's very simple. So, I mean, this is calculation. I'm going to make things easy for us using graph. We have probability distribution. And now I need to select what is geometric. Event probability is 0.15, means 15%. Okay, shaded area, I'm just going to have here, let's say 5. So it will give me the complete distribution. And now it is asking 7. So I'm just going to put the cursor x equal to, because it is asking, 7th, which is how much? 5%. So you can see this is the answer, 5%. On 7th call, so similarly, you are, let's say you are running any event, you know that, any business event, what is the probability that you will win the project? What is the probability that you will, first sale will come on 8th person will come. So such situations will be taken care by geometric distribution. So here, this is a geometric distribution. You just put, here fingers, I mean, on particular thing, 6, 7, and you get it. So now I come over here. So this is now, random variables. So I'm not going to cover because this is not part. So this is chapter number 6. Any question related to chapter 6, don't feel hesitate to ask me. See, Jason, this is, basically purpose of this learning so that you can apply in your life and you can see, in professional life, and you can visualization give you better understanding of, what is the event one, or you can do either way. If you understand the concept, I mean, both are fine. So any question related to this? If you not, let me go to the last 4 questions of last module. Where am I? So I think I have data right here somewhere. So I think what I asked, I don't remember question, but for example, this is age. I'm going to do basic statistics of age, and earthquake occurs 3 times in a year. What is the probability that, Jesse, that is a chapter number 7. That is chapter number 7. So I will explain in the next class tomorrow. That is exponential. That is exponential distribution. So here I'm just going to do age and fair in pound, 2 variables I have. I need, few thing. For example, okay, I need median, maximum, minimum, these 5 numbers. Can you see this, Margarita?
Yes, I see. Thank you.
Yeah, so please look, I think my question I have not read. So basically this is our data. This is minimum, let's say age variable. Minimum is 0.17. Maximum is 74. I think I also explained in last session. The median is 30, which is right here. The Q1 is, what is 23? And Q3 is 38. Now I think my question is, what is the top 25%? So basically this has been divided into 4 parts. First 25, second 25, third 25, fourth 25. So 4 quarters it has been divided. Now my question was, what is the middle 50% range? So middle 50% is also called interquartile range. 38 minus 23, which is 15. What is the top 25% range? So 74 minus 38, which is, you can say to 36. What is the, bottom 25%? So 23, I mean, approximately you can say 23 minus 0.17. What is the top 75%? Top 75% is, I think, this 74 minus 23. So basically all the question, if I am, I haven't seen, I ask related to this, based on these numbers. If related to fair in pound, you just, you have these minimum, maximum, Q1, median, and this. Is it making sense?
Yes, I think it does right now. So we'll try it again.
I mean, don't do now because I think the deadline is over.
Oh, no, this is just for me to
Okay.
understand because, yeah.
Okay.
Thank you.
Most welcome. Any other question anyone has? Otherwise, we will meet tomorrow. Bye-bye. Good night.
Good night, sir. Bye-bye.
Thank you.
Thank you.
Bye.
Thank
Bye.
you.
Thank you.
Thank you. Good
Bye.
night, sir.
Bye. Bye.
Good night, sir.
Bye. You will get the recording very soon. Yeah, I will send the link of, you can see in announcement, please, so you will see that.